This is MAT 175, Lesson 27, Section 8.2 and 8.3, Law of Sines and also Law of Cosines. We'll start with the Law of Sines. And with the Law of Sines, basically, if we do not have a right triangle, then we cannot use right triangle trigonometry. Instead, we have to use the law of sines or the law of cosines. And the difference is, with the law of sines, you have to have an angle and a corresponding opposite side to that angle. So here we have opposite angle and an opposite side. Here we have an angle and its opposite side. Here we have two angles, but we can find what this angle is by taking these first two angles. Let's call this angle 1 and angle 2, angle 1 and A2. And if we take A1 plus A2 plus, let's call this A3, then those three angles add up to 180. Now we cannot say two of the angles add up to 90 because we don't have a right triangle. So basically we take the sum of the first two angles and subtract it from 180, and we get angle 3 minus the sum of A1 and A2. And so we get A3. And then once we get A3, then we have that corresponding angle and its opposite side. So the formula for the law of sines is sine of angle A over its opposite side A. So if we're looking at a triangle here, and this is side A, angle B and angle C, then this would be side A. Okay, so that would be angle A and its opposite side, side A. And here is sine B, sine of angle B. And so now here we have angle B and its over its opposite side of length B. And then the third one is angle C over its opposite side of length C. And so we can use basically any combination of any two of these, either the first and second one, or the second and the third one, or the first one and the third one. And so this would be the law of sines. So let's take a look at some problems. And so here we have angle A, angle B, and angle C. We know that all three angles in a triangle add up to 180 degrees. So let's take a look at triangles that have a side angle and an angle, or angle side angle. So in this case, we have angle A is 40 degrees. So we'll call this angle A here. And angle B is 60 degrees. And side A is 4. So we don't have a right triangle here. So we cannot use right triangle trigonometry. We cannot use SOHCAHTOA, basically. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Cannot use that because we do not have perpendicular sides. We do not have a right triangle. So we have to use either the law of sines or the law of cosines. So here we have an angle and we have a corresponding opposite side. So we can use the law of sines. And so with that, we can say sine of 40 degrees over 4. And then since we know 60 degrees, we can go ahead and say that's equal to sine of 60 degrees over side B. Alright, so basically we multiply B to both sides, and we multiply 4 to both sides. So basically what we're really doing here is we can just cross multiply here. And so we get B sine 40 degrees equals to 4 of sine 60 degrees. And then we can divide by sine, still trying to isolate B, so we can divide sine 40 degrees. And so when we do that, you have to be careful because you have to close the parentheses on the sine, the top sine 60, because if you don't, the calculator will include the denominator in with the sine 60, and you don't want that. You end up getting an incorrect answer. So in this case, side B is going to be, we have 4, and then we put in here sine of 60. Oops, 60. There we go. Divided by, close the parentheses up, and then sine of 40 degrees. Of course, we checked to make sure that we were in degrees in our mode, and we get 5.389185421, and it goes on and on and on. Rational number. So we're going to say that this is 5.4 for side B. 5.4. Okay, now for side C, we can just figure out the sum of these two side angles is 40 plus 60 is 100, and then 100 at 180 minus the sum of those two, and we get 80 degrees. So we know that angle C is 80 degrees. So with that, now I like to always use a side that was originally given, because unless you save this into X, the B, the 5.4 into X, you may get some round off error. So I would rather use the sine 40 over 4. Sine 40 over 4 equals to sine 80, and now we can find side C. So again, we're going to cross multiply, right? And so this will be 4 sine 80, and then this will be C of sine 40 degrees. And so we divide sine 40 to both sides. Divide sine 40 degrees to both sides. And so we divide sine 40 degrees here. And we get side C equals, and so this will be 4 sine 80, close it, divided by sine 40, and we get 6.128, and it goes on. So we're going to round this off to 6.1. And so we've solved our triangle. We've gotten all our angles and all our sides. And so they did the angle first, which, it really doesn't matter which order you go in. And so we get 5.39, and we got 5. We used 5.4 and 6.13. We used 6.1, and so we got the same answers. Okay, so there's some different ways you can do this, but as long as you get the same answers, that the answer here. Let's see, they use sine 40 over 4, and then got B, and again they use sine 40 over 4. So they used the original values But you could have used sine 60 over 55.39, as long as technically you could have done that, but you have to be careful with the round off errors, so it's better to just stick with the original values that you were given and work with those. Okay, now this is an obtuse triangle here, and so we can, you want to ask yourself, can I use the law of sines here? And the answer to that is yes, we can. Because if we take 35 degrees plus 15 degrees, okay, that would be 50 degrees. And so we subtract 180 minus 50, and we get 130 degrees. Okay, so from here, we know this is 130 degrees. Well, it looks like, obtuse angle looks like it could be 130. So, you want to do like a kind of like a check on that. That looks like that could be 130 degrees. Okay, if it's an acute angle, then you know something's wrong. Okay, so now we have our angle and our opposite side. So what will we use for our law of sines? You should have said that we're going to use sine of 130. Rewrite that. Sine of 130 degrees over 5 equals 2. And really at this point it doesn't matter if you're looking for side A or side B. Now students, sometimes they can have some difficulty trying to figure out what is the opposite side. Well, first of all, the opposite side is not adjacent. It's not touching. So 5 it would be adjacent. 5 would be, one of the sides for 35. B would be the other side for 35. So that would have to make A the opposite side. So we can say here sine of 35 degrees over A. Alright, and so now we do our cross multiplying, and we get A. Make sure I give myself some room here. A sine 130 degrees equals to 5 sine 35 degrees, and then we are going to divide both sides by sine of 130 degrees. We're going to apply that to both sides. And so we get here A equals, and so on the calculator we have 5 sine of 35 degrees close parentheses divided by sine of 130, and we get 3.74375, and it goes on and on. So we'll use 3.7. So A, side A is 3.7. Okay, now we want to find side B. Well, we can't use the Pythagorean theorem because we don't have a right triangle. So we have to use the law of sines again. And so again, we can use sine of 130 degrees over 5 equals to, now what angle are we going to use this time for side B? You should have said 15 degrees, because the 5 is touching the 15 degrees. That's not an opposite side. The 3.7, that's touching 15 degrees. That can't be an opposite side. So side B is opposite 15 degrees. So this would be sine of 15 degrees over side B. Alright, so again we cross multiply, and this would be b sine 130 equals to 5 sine 15, and we are going to divide sine 130 on both sides. 130, and so we get side B is, we're going to get 5 sine 15 degrees, close it up, divided by sine of 130, and we get 1.689, we'll say 1.7. Okay, and so we get 1.7 here. Okay, and so see, there we go, we found our angle 130, and there we found side A, they use 3.74, we use 3.7, so whatever they want to round it off to. And we use 1.6, they use 1.69. Okay, and so we get our angles, our third angle, and our two sides that we were looking for. Okay, and this next one we are going to do that one in class, so we're going to just move right on past that. And this one too, we're going to do this one class 2. Alright, now we're going to move on to the law of cosines, section 8.3. Now, if we don't, in our triangle, if we don't have an opposite side that with an angle, then we can use the law of cosines. And so the square of one side of a triangle equals to the sum of the squares of the other two sides minus 2 times the product of the cosine and their included angles. So with that, if we have this triangle such as angle A, and we have our side A, and we have angle B and our side B, and we have our angle C and our side C. Now here they have side C squared equals to A squared plus B squared, so that looks like, similar to the Pythagorean theorem, but it's different, because here we have minus 2 times, and then these same two sides here. So the two sides that are on the right, the right side of the equal sign, they go multiplied times 2, and then cosine of angle C. Now notice angle C and its opposite side, side C. So whatever since we don't know what the opposite side of angle C is, then we have to use cosine of angle C, and its opposite side is on the other side of the equal sign. And so that's how we find it. Okay, so these others are basically the same as the first one. Here we have b squared, so that means the other two, a and c, are going to be on the other side, a squared and c squared minus, and then here's a and minus 2 times a and c. And here's angle b, and here's side b on the other side of the equal sign. And the same thing with the third one, side a, angle a, so that would make this b squared and c squared minus 2 times b and c. Okay, so really, as long as you know the first one, then that's the only one that's the others, they just follow the same pattern as the first equation. Okay, so let's take a look at some problems. Alright, we want to solve the triangle, side A, is 3. So this is side A here, or I'm sorry, excuse me, side A is 2, and side B is 3, and angle C is 60 degrees, but we have 60, and that's all we have. But our opposite side is not given, and we cannot use the Pythagorean theorem. Why? Because you should have said because we don't have two perpendicular sides. We don't have an angle that's 90 degrees, so we cannot use the Pythagorean theorem. So we have to use the law of cosines here. Alright, so basically we can say here that c squared is equal to, and then a, that'll be 2 squared, plus b, that would be 3 squared, minus 2 times each of these two. 2 times 2 times 3. Okay, so we're not squaring these, we just put the bases 2 and our sides 2 and 3. Cosine of 60 degrees. Okay, so we get here c squared, and from here you can go ahead and apply the whole thing into the calculator straight out. But I'm going to go ahead and work this out. So this will be 4, and what you can do at this point is, okay, so you're going to get 4 plus 3 squared is 9, minus 2 times 4, 2 times 2 is 4, times 3 is 12, cosine 60 degrees. And so what you can do here is you can go ahead and just apply the whole thing in the calculator. So you could apply the whole thing in the calculator, but you'd have to apply the square root in this whole thing, and you can do that whole thing in there. And so if I ask for you to show work, this is, you could just show me this part here and then go ahead and punch the rest of it in the calculator and get your answer. Okay, so you now on your calculator you may have to have open parentheses here and this may be open parentheses, and you may have to close the parentheses for the angle, and you may have to close parentheses on the radicand depending on the calculator that you have. Alright, so we're going to have here 4 plus 9, that's going to be 13. So we're going to put in here second square root, and we're going to put in here 13 minus 12 cosine. Now this is 12 times cosine, so order of operations is you have to multiply those two first. So that'd be 12 cosine 60, and then close parentheses, and we get 2.6457, and since they've been rounding to the nearest hundredth, we'll go ahead and do that, and we get 2.6457, so that'd be 2.645. I mean 2.65 for side C. 2.65. Now, once you get that opposite side, now you can use the law of sines at this point. So what we're going to do is we're going to store this 2.65. We're going to store that into x. Store it into x. Alright, and now at this point we want to find angle B next. Okay, now you could have found angle A next, I mean that really doesn't matter. But we're going to go ahead and find angle B next. So at this point we can use the law of sines. So we can say sine, and we know we have 60 degrees over 2.65, which we stored into x, equals 2 sine angle B over 3 is the side opposite angle B. So we have to use 3, cannot use 2. So at this point we can multiply both sides times 3. Okay, so we don't want to cross multiply because here we can just get rid of the 3 and now we just have sine of angle B. And so here we have 3 sine 60 over 2.65. So we're going to put in here 3 sine of 60 degrees, close it up, close the parentheses on that, divided by, since we stored the 2.65 into x, we'll put over x. And we get here 0.89198, and it goes on. 0.98 rather, 0.98198 dot 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 dot, and it goes on. So at this point, what we've got to solve for angle B. So what do you think we need to do to solve for angle B? You should have said we have to apply the inverse sine to both sides. We have to apply the inverse sine to both sides. Okay, and so angle B, let's see what we get now. So we put in here second and inverse sine. And then we're going to put in here second and answer, because that's what our answer is for this, right? So we just use that answer, and we get 79.10660535, and it goes on. So we're just going to say 79 degrees. Okay, so based on how much, what they want you to round it off to, we could round off 79, we could round off 79.1 or 79.12. It all depends on what they want to round it off. But we're going to round it off to just a whole degree, so that's 79 degrees. Now, we have the two angles, and so now all we have to do is find the third angle. So how do you think we're going to find that? Well, we can just add the two angles that we know. 60 degrees and 79 degrees, and so we're going to add those two, and so we get 9 there, and we get 139. So now we're going to take 139 minus 180, and so that's going to be 1, 7, and 3, that's 4, so that's going to be 40. We're going to have angle A is 41 degrees. And that's how we solve our triangle. Okay, and so we use the law of cosines. And so they use cosine of 60 is 1/2. So, and so they got the square root of 7. Well, if you take the square root of 7, you get 2.64, which is what we got. So if they ask for it in exact form, then I guess you'd have to do it that way, but we'll have to see. And so they went ahead and used the law of cosine again and got 40.9 degrees. And we got 41. So, we were close enough to that. And then the other angle, then what they did is at that point was we went ahead and found the other angle at 79. We used 79, they used 79.1. Okay. So if they want an exact form, then you'd have to do it like this. So let's see what they want to do. Okay. And that's all we're going to do for this video. The rest we will do in class.